These are notes number 11, triangle congruence. They're the first set of notes for this week. Make sure you have your paper set up correctly with your name, date, period. This is chapter 3, section 2, and it starts on page 129. The essential question for these notes is, how do I prove two triangles congruent using the SSS and SAS? As we go through notes, you'll figure out what those stand for. You should have the warm-up already done. We should have done that in class. So we're going to just move on up. These actual notes are not that much, but we will do some examples. So, okay, you will probably have to pause to copy all of this down. Okay, so pause if you need to, and I'm just going to start going, okay? So what this says is a vocabulary word, congruent polygons. And in congruent polygons, all corresponding parts are congruent. What that means is like, I'll show you an example in a second, but it means any part that's matches up with one shape to another shape. So like maybe it's a triangle or a square or a rectangle. It doesn't matter. A polygon, it could even be like a star shape. The corresponding part on a congruent shape, the same one, will be congruent. It's, again, congruent means same size and shape. And that's from the section before this, 3-1, which we are skipping. So I'll just show you what it says real quick in that one. Again, this is 3-1, and we're just skipping it. This is page 121, if you want to check. So this is a little review about what you should have learned in Math 1, although you may not have. A congruent figure is basically same size and shape. It has like corresponding sides and corresponding angles, which means that they match up and correspond and they're congruent. So these are showing some of the different ways you can have rigid motion with different shapes. You can have slides, which are also known as translations. You can have a flip, which is a reflection, like a mirror reflection, it kind of flips over. And then this one is showing a turn, which is a rotation. So even though the shapes, they look different, if you were to flip that one back, it would match up perfectly. If you were to turn that one back up there, they would match up exactly. So you do see two congruent shapes, and they've been either they slid, or it flipped, or it turned. Okay, so feel free to look at that for a little more information. Okay, so congruent triangles, this is on page 129. So feel free to look in your book. It looks very nice in the book. So it says if all these different angles are congruent, F and J. So look at F and J. And then G and K, G and K. And then H and L. If those are all congruent, and then all of these different sides or segments are congruent, then down here, triangle FGH is congruent to triangle JKL. So if you have every angle congruent and every side congruent, then the triangles are congruent. The order of the letters must match with the congruent letters. So see how F and J are congruent? When you write it out right here, F and J have to be in the same position. So first, it could have been last or middle, it doesn't matter. G and K are congruent, those two. So G and K have to be in the same position. So they're second, but they could have been first. It doesn't matter if you go G, F, H, but here you'd have to start with K, K, J, L. So again, the order of the letters must match with the congruent letters. So I'm going to mark the congruence. We haven't done this with triangles yet, so it's basically markings we've done already. So if I'm going to mark that F and J are congruent, I can just do one little arc. Congruent angles. And then I just want to show you that that's where F and J are. So I'm using color to show you guys. And then for angle G and angle K, I'm going to do two arcs. 1, 2, and then the red is just to really show you the difference between them. And then I'm going to just also show it here. So they are congruent. That's why they have to match up and be in the second position. And then get something different, green. Angle H and L are congruent, and I'll go 1, 2, 3 arcs. 1, 2, 3. So we do that so that you can mark the different angles which are congruent. And again, it means they have the same size and shape, and congruent angles have equal measure. So just for example, maybe angle F is 60, and so is J. Maybe angle G is 105, and then angle K is also 105. So they have the same measurement, but congruent just means they have the same size and shape. And then H and L. Okay, and I'm not going to show the color with the sides, but the sides, it's the same thing. Okay, so that's for congruent triangles. If you know two triangles are congruent, then you know every angle matches up and they're congruent, and every side, oh, I forgot to mark the sides. So it says FG and JK is congruent, so I do one little line, one little mark, and then I do GH is congruent to KL. I'll use a different color. What is that one? GH. Okay, so I'll do 2 marks and then 2 marks. Okay, and then the last one, FH is congruent to JL. 1, 2, 3, and 1, 2, 3. Okay, so I'm just showing how basically we would say that's how they correspond. It's how they match up. Okay, so here is the next postulate. Again, pause if you need to. Okay, that's pretty good. Okay, so we've got, we're gonna, by the end of this chapter, we're gonna have a lot of theorems, but, and some are postulates. So today we're gonna go over 2. So postulate 14 is our side, side, side. So that's what SSS from the very beginning in the essential question stands for, side, side, side. So it says if 3 sides of one triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. So if, without looking at the angles like we looked at up above, if we just know about the sides, if 3 sides are congruent, then we know that the 2 triangles are congruent. So if it's like given to you, or if you're proving it, you would know, okay, so AB is congruent to DE. So I'll do 1 mark there, 1 mark there. And again, pause if you need to, and then you'll be caught up. And then we'll have segment BC congruent to segment EF. So I'll do 2 marks there and 2 marks on segment EF. All right, and then the last 2, AC is congruent to DF. So 1, 2, 3, 1, 2, 3. So once you've marked it like that, you can really tell that those 3 sides are congruent. And so therefore those 2 triangles are congruent. Okay, so again, that's the side, side, side postulate. And we'll do some examples from the book right after this so you can practice. Okay, and then this is your last one. Okay, so postulate 15. Once you get the hang of this, you'll see like, oh, okay, SAS is side angle side, and you'll know what that means. So what this one says, again, pause if you need to copy it. If 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. So it's really important that it says the 2 sides and the included angle. You have to have 2 sides, and the included angle is right in between. It's the angle that touches those 2 sides. So here we have an example. So I'll read it first and then we'll mark it up. It says if AB is congruent to DE, so AB and DE, and then we have angle A and angle D congruent, and then AC is congruent to DF. AC is here, DF is here. So we have a side and an angle and a side. Over here, a side and an angle and a side. So if that is true, then the 2 triangles are congruent. And again, the order of the letters matters. If you go from A to B to C, then this one has to be D, E, F. You can't change the order of the letters. They have to correspond and match up with the congruent angles and segments. Now let's mark it real quick just so that we can see it better. So AB is congruent to DE. That'll be a 1 and a 1. And now we have an angle. So it's mixing up marking sides and angles. So remember, sides are marked with little lines, and then angles are marked with an arc. So I have to find A, do one arc, and D, do one arc. So look for the difference and always be thinking, is it a segment or is it an angle? And then we have segments again. AC is congruent to DF. AC, I'll do 2 marks, and then DF gets 2 marks. So when I look at these, I always think, is it side, angle, side? It has to go in order, side, and then an angle, and then a side. So I've got side, angle, side, or you could look at this one first, side, angle, side, and they match up. You can tell that they're corresponding with each other. So that is the side, angle, side postulate. All right, so now we're going to take a quick look in the book. This is page 129. This is what we wrote in our notes about the corresponding parts of the congruent triangles. Okay, and you can read that and get more information on your own. What I want to do, I have to rearrange this real quick, is this flow proof. Let's see if I can show it. Right there, that one. So the bottom of page 130. Okay, it's a little weird looking, but you can see what you need to see. So we are going to complete this complete the flow proof. We are given certain information, and then we're trying to prove that these two triangles are congruent. So again, a flow proof kind of just starts with one thing, goes to another, but then there's another thing, and it goes to that, and then that one also goes to that. So this would be your conclusion. That would be what you're trying to prove. Everything is pointing to that conclusion. So let's go ahead and see what we've got here. They do have the diagram and it's marked already. So they have JK is congruent to LM. That's given. I'll just do a red mark there. It's here. And JK congruent to LM right there. They already marked it, so I'm not going to try to mark it again. And then we've got the next thing that's given, JM congruent to LK. So they have this one. So right there, JK or JM congruent to LK. And it has A, we have to fill that in. What's the reason? So you have to think, what's the reason that JM is congruent to LK? Well, it's the second part of the given. So it's actually a pretty easy one. We just have to write given. All right. And then the next part is it says KM is congruent to KM. So that would be this one. I'll mark it. Oh, I've got to get a different color. I'll mark it with 3 lines. 1, 2, 3. Again, it's segments and segments and more segments. There aren't any angles. So the reason whenever you have, I always call these a shared side, but it's the same exact thing. You're saying the same thing is congruent to the same thing. And it's shared in one triangle and shared with the other triangle. So whenever there's a shared side, we write reflexive property. It is a property that's on the list. So reflexive property, but if you want, you can just make a little note. That's if it has a shared side. If they both contain that side in the triangle. So shared side, okay? So that was for B. And then all the arrows are pointing to C and D. So what is congruent to what? That's where we have to write which triangle is congruent to which triangle. So when we name a triangle, we have to put this little triangle symbol, and then we'll write the 3 letters at each vertex of its angles. So it has to go in order though. So one easy way that I always do is I can look at how they name the segments. So the first one I can start with J, K, and then I just have to see what's the last letter. So if I go J, K, it goes up to M. So J, K, M. And then it already has congruent there. So D, I just have to fill in the other triangle. So if I'm doing JK first, LM is congruent. So I have to go L first and then M. And then look at the diagram. It goes from L to M and then back to K. So it's really important that you are careful with the order because every congruent part has to match up. And then I can kind of check it by looking at like, okay, JM is congruent to LK, JM, and LK. So see how J is in the same position as L and M is in the same position as K. So I can check it with that just to make sure. All right, so now we're going to do just a few more problems. This is on page 133. So we're actually going to be practicing now. Would you use side, side, side or side, angle, side to prove the triangle is congruent? If there is not enough information to prove the triangle is congruent by side, side, side or side, angle, side, write not enough information. And then you have to explain your answer. Okay, so for number 5, I can see one side is marked. So those sides are congruent. And then 2, another side is marked. But I need 3 sides or I need an angle in between. So I do want to show you guys there's one thing you can do here. You can always mark the vertical angles are congruent. That angle there and that angle there. So you can always mark vertical angles congruent. But even if I mark that, it's not side, 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 and it's not the included angle. The vertical angle is actually like not the right angle to count for side, angle, side. It would have to be angle T and angle R. So we actually have to say not enough information to prove that they're congruent. Okay, but I do want you to see how whenever you have vertical angles, you can mark vertical angles are congruent. All right, so let's take a look at number 6 now. I can see one side is congruent. BA is congruent to DC. And we could even write that out. It's kind of good to practice writing it. And notice how I went B to A because A has the angle marked. So I have to start at D to C. So I'm trying to make sure I have them in the correct order. And that's given from the picture. And then I do have angle A is congruent to angle C. And then I just need one more thing. It looks like we're going for side, angle, side. So maybe we can get one more side. So I am noticing that these two triangles share this side. Okay, so I can mark it and then I can write that side AC. This is where it gets kind of weird. So for the first triangle, that's side AC, but on the other triangle, it's actually, you have to start at C. It's CA. You'll get the hang of it. It might seem kind of weird now. So on this one, I can say side, angle, side. They don't want you to write the triangles congruent, so that's good enough. And then I want you to remember that that's the reflexive property. Okay, that way you get used to that. It's reflexive property whenever they share a side. Okay, we're going to turn the page and go to the next page and do a few more problems. Remember, at the end of the week, when you turn your notes in, you must include pictures of this bookwork. Okay, so for 7 and 8, it says in triangle pen. So I'm just going to draw a triangle and name it PEN. Name the angle that is included between the given sides. So we're practicing for side angle. All right, so we're going to go ahead and check if this is a side angle side, which angle is included. So I think it's easy to just kind of trace. PE is from P to E. EN is from E to N. And we have to say what is the included angle. So the included angle would be this one, the one that's formed from those two sides. So angle E, and that's it. Okay, so let's look at the next one. Draw a triangle PEN. Again, it doesn't matter what it looks like. And then I'm going to use a color to trace NP and PE. So NP from N to P and PE. So I can tell that the angle would be right there, angle P. Okay, it doesn't matter which way you draw the triangle, as long as you do PEN. In some way, PEN, it doesn't matter where you put them. It'll always end up being angle P that's included in between those two sides. Okay, so the next one, it says in triangle hat, between which two sides is the given angle included? Okay, why don't you guys try that one? Well, I'll do A, and then you guys can try B. So again, it doesn't matter how this triangle looks. You could draw it however you want. So I'm going to have H, A, T, and it says if we're looking at angle H, what are the two sides that this angle is included within? So I would just basically trace the angle, and then I just have to name those sides. So it doesn't matter if you name the side AH or HA, but it has to have those letters. HA, I don't have to put that it's congruent. And then the other one is HT or TH, it doesn't matter. I'll do TH on that. It doesn't matter the order as long as you are writing the two sides. And you guys tried T, same triangle, but now we're going to look at angle T, trace the sides that form T, and then name them. All right, and then for 9 and 10, these are the last two that we'll do. Name the postulate you would use to prove the triangle is congruent. Right now, we only know side, 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 or side, angle, side. So when I look at 9, I am noticing one side here matches with that side there. They're congruent and corresponding, and then those two sides. They also have a vertical angle included. So don't forget, we can always say that vertical angles are congruent. So this looks a lot to me like side, angle, side, side, angle, side, and it is the correct angle. It's included between the two sides. And that's all you have to do for that one. Go ahead and try the next one and see what you can do. It's very similar to some of the problems we've done. Just notice that we do have one side there and there, one side here and here, and then maybe there's an angle or maybe there is another side. So you figured out number 10, and I want to see it in the notes when you turn it in at the end of the week. All right, so what you should do now is you go on to alex.com and you're going to do Alex assignment number 11. If you need help, we can go over it the next time we have class. So please bring me your questions and I can answer them the next time we have class.